To my channel. So in the last video we have seen what is minimum spanning tree, and also we have just covered the first algorithm of that, Prim's algorithm, and we explain all the step by step process of that, how to reduce or minimize the cost, and also how to connect all the vertices without forming a cycle. So which is the goal of minimum spanning tree. Okay, so now in this video we'll just cover the next algorithm, Kruskal algorithm, which is very easy in compare with Prim's. So if you haven't watched Prim's algorithm, please watch that video and come back to this Kruskal algorithm video. Okay, fine. So let's start today's topic, which is nothing but Kruskal algorithm to achieve minimum spanning tree. So we know what is minimum spanning tree, which is nothing but where we have to connect, okay, all the vertices. Okay, these are the all the vertices. Now in this graph there is a cycle, there is a loop. Okay, this is called a cycle. Actually, like you can see here, so we're starting by A and ending A. Okay, so we have connected it, and it works for the undirected weighted graph. Okay, so you can see this is the undirected. So undirected means that there is no direction given and it is weighted, which is nothing but a numerical value will be assigned for an edge. Okay, so this is how you are going to have a graph for undirected weighted graph. In this we are going to connect all the vertices with a minimum total cost is with a minimum cost. Okay, where we will be having this numerical value with a minimum value and without forming a cycle. This is our goal of minimum spanning tree, and we'll achieve that goal by using a Kruskal algorithm techniques. So here is a given graph. Okay, so how we are going to solve it? So in Kruskal algorithm, what you have to do is we have to take up the edges. Okay, so list out all the edges and its weight along with its weight. Okay, so you have to take up all the edges. Okay, so starting from A, you can just have AB, AC, AD, and AE. Okay, and you can list out all the weight for that. From the A, you can just have what are the vertices like possible. Okay, so here we do not worry about the adjacent vertex. So you have to worry about only the edge and the weight. Okay, you can just have AB the weight 1 and AC the weight 7 and AD weight 10 and AE 5. You can see here. So AB the weight, whatever the numerical value is assigned for that, you have to mention that as weight. And AC is, this is the AC edge. Okay, so this is your edge, okay, where it is connecting the A and C. So we have weight of 7. So we have given that. Again for AD it is 10 and AE it is 5. Okay, so all the thing we have given according to A. And next we'll just take up B. So here for B we have an edge like BA and BC. So BA and AB is same. Okay, so no need to replicate again. So we have only BC which is not given. So we have given BC 3. And again from C you can just take, we have CA and CD. C is also given as AC. So no need to repeat it. So we'll just give only CD. Okay, CD is 4, and from D we have DA and DE. Okay, again DA is given as AD here, so already is given, so no need to give again DA. So we'll just take up DE. So DE2. Is there anything left? Okay, you have to see that how many edges are there. So we have 1, 2, 3, 4, 5, 6, 7. So 7 edges. So you can just count that whether the 7 edges are there. Okay, so you can 1, 2, 3, 4, 5, 6, 7. Totally 7 edges. We have just completed all the edges, and along with weight we have just given. So this is the first step you have to do. Okay, you have to take up all the edges along with the weight, and you just draw a table and just mention it. After that, what you have to do, second step, you have to short the edges, okay, given above. Okay, these are the thing. Okay, we have to short the edges based upon the numerical value in the ascending order. Okay, okay, so we have to short the edges above in the ascending order. Okay, order of their weights. So we have to based upon the order. So we are going to short the order of weight based on the along with the edges. So now you have to do what? You have to short it in the ascending order. So ascending order means like from small to big. Okay, so you have from here you can just see the smallest is 1. So we have 1 as such, AB will be given, and the next is like after 1 we have 2 here. So 2 comes after 1. So 2 is here, and D along with the edge you have to take over and we have to short it in the order. So you can see all the weight has been sorted in the ascending order along with its edges. Okay, that's it. Now what you have to do is you have to draw the edge now. Okay, you have to draw the edge. So once you sort it out, you have to do first, you have to draw that. First step is you have to start adding the edge along with its weight. So we have AB connectivity of 1. Okay, so we have A and B connect with the weight 1. Next is what? We have DE with the weight 2. So add that. Okay, you can just add like this. Okay, we have AB 1 and DE 2. And then what is the third one? We have BC. So we have BC with the weight 3. So we have already this thing, right? We have to now we have to extend B with a C with the weight 3. Okay, so now you can see here. Okay, so add the edge BC with the weight 3 to the MST. This is minimum spanning tree. So now we have the thing which is not creating any cycle or loop. Okay, again this is also minimum spanning tree, but still we have edges, right? So we have to add that. Now what we have to do, we have to pick 3D, okay, sorry, CD with a weight 4, that you have to add it. Okay, already we have here BC, right? So now we have DE. So there is no connect between CD. Now we are going to do this. Okay, now we are going to connect C and D with a weight 4. Now we got this kind of graph. Okay, now next edge is like AE. Okay, AE. So we have a connectivity now. So you can see here we have this like, okay, so we have AE. So if it's just after that, if you're just picking up AE with weight 5, include this edge, will create a cycle. Okay, yes or no? So see, if you add A and E, now what happens? A cycle is getting formed. Yes, so you have to reject that. Okay, you have to reject that edge. If I'm just adding this AE, again I'll be getting a cycle which is, okay, not applicable for a minimum spanning tree. Okay, if you are forming a cycle, then it is not a minimum spanning tree. So our goal is to create minimum spanning tree. So to avoid that, so we are just ignore AE edge. Okay, so just we ignore this. Now what we do, we just pick what is the next thing? A and C. We will just try with A and C. Is there any cycle is getting formed? Yes. Again, you are just adding up A and C will form a cycle. So we also ignore that. Okay. So next is AD. What happens if you are adding up the AD edges? Again, it is forming a cycle. So you have to ignore that. So you can see this, all the vertices has been connected. All the vertices has been visited. A is also visited, B is also visited, C, D, E, all things are visited, and it's also there is no cycle. What is the total cost? You have to add up 1 plus 3, 4, 4 plus 4, 8, 8 plus 2, 10. Total cost is equal to 10. Okay. So whenever you add up a edge and if it is forming a cycle, you just ignore that. So we have just ignored these 3 edges. We just formed a minimum spanning tree by these 4 edges. Okay, and we have added all the weights, so total weight will be 10. So you can see the last output. So now we have just so the final minimum spanning tree is, this is the final minimum spanning tree. So after ignoring AE and AD, this is our final minimum spanning tree, and the total edge of that, sorry, total edge cost of that is AB we have got it 1. So 1 plus 2 plus 3 plus 4, which is 10. So total cost of this minimum spanning tree is 10. Okay, that's it. So once you're given a graph for a Kruskal algorithm, what you have to do is you have to take up all the edges. First count the number of lines, okay, number of links, okay, 1, 2, 3, 4, 5, 6, 7, 8, sorry 7, sorry 7. Okay, so 7 lines are there now. So you can just verify it, cross verify with the count whether all the wedges has been given in the table or not. If you have missed it here, surely you will be like making a wrong minimum spanning tree in the output. So always your like first step should be very correct, then only you can just achieve the minimum spanning tree in a right way using the Kruskal algorithm. The first step is very important. So you have to take up all the edges and write the weight along with that, and then after that you sort it ascending in the ascending order based upon the edges and the weight. Okay, once it is done, you just start drawing a graph, okay, by adding all the edges along with its weight. Okay, and see that every edge, whenever you are taking and drawing in a graph, we see that whether there is a cycle is forming or not. If that is leading to a cycle, please ignore that edge. Okay, and then you can just repeat the next edge and just try with that. If there is again no cycle, please include that edge in the graph. If it is not, again it is not forming a cycle now, please ignore it. Okay, so the thing is like you have to take edge and add the edge to the minimum spanning tree along with its weight. If that edge is creating a cycle, please ignore that edge and just go to the next edge and just try with that. Again, if it is creating a cycle, again ignore that also. So whichever edge is not forming a cycle, include that edge into the minimum spanning tree. After adding up all the edges, after completing the table, okay, so that will be the final minimum spanning tree. Okay, after adding and after ignoring, okay, whenever it is necessary we'll add, whenever it is necessary we ignore. Okay, so after that we form a final minimum spanning tree, and after that you have to take up all the weights and sum up all the weights and just give the output value. Okay, that will be the total cost. So we achieved the goal of minimum spanning tree. The first goal is to minimize the cost. So we have just minimized the cost, and second goal is we just form a graph without forming a loop or a cycle. Okay, so this is how you solve the minimum spanning tree by using Kruskal algorithm. If you have any comments, please ping me in comments and query. Okay, and also you can approach me so through mail also. Okay, so thank you, happy learning.